phosphates and your 1,2-phosphates. Going back to chemistry nomenclature, the alpha phosphate is the phosphate closest to the main part of the molecule, the beta is the next one, and the gamma is the furthest one out. That's when we were talking about our alpha carbons or our beta carbons. It's just a common nomenclature system to let you know relatively which carbon you're talking about, in this case which phosphate you're talking about. So what the magnesium does is here we've got our negatively charged oxygens. This one is 1 minus, magnesium is 2 plus. It brings those two things together. And this does two things. One is it changes the shape of the ATP, which allows it to interact with these ATP-dependent mechanisms. The other thing it does is, so if ATP is floating out in free space, you're minimizing the damage that can be done by those charges. Now you have one charge over here and one charge over here, and they're very far apart, as opposed to a bunch of different charges pretty close together, which could inflict a lot of damage on a lot of other molecules. So magnesium protects, and it also changes the conformation so that ATP can bind. So anytime we're talking about an ATP-dependent mechanism, right, we are talking about ATP bound with magnesium. And it's very unusual to see ATP by itself. Adenosine diphosphate, the same idea. You're binding, except there are only 2 phosphate groups, so you're binding closer to the adenosine part of the molecule. So this is what I want you to know that magnesium does. We're going to talk about some other things that magnesium does, but this is really what I want you to know what magnesium does. I want you to know where it binds, how it binds, why it binds. So I'll put that back within the outline.
Where, how, and why?
Okay. Okay, so where does it bind? In triphosphate and diphosphate forms.